This is Algebra 2, Unit 4, Lesson 4, and today we're going to learn how to simplify algebraic fractions by factoring. You do not want to try to attempt this section until you are extremely comfortable factoring trinomials. If you're not comfortable with factoring trinomials, difference of squares, sum and difference of cubes, you need to get more practice on that first. This section can be very confusing if you're still really slow at that process. You need to be able to factor trinomials quickly so that these type of problems don't take so long. So if you're finding that you're still getting a lot of trinomials incorrect or that they're still taking you a while to solve, you want to practice those some more first before you attempt this lesson. When I have trinomials within a fraction, here I've got a trinomial in my numerator and I've got a trinomial in my denominator. It's very tempting for students to try to just cancel things out. Like we learned that if you have a number over itself, like 5 over 5, well, you can cancel out. Or if you have 5 over 10, you can cancel out. That would be 1/2. So we've learned that we can cancel common factors out of the numerator and the denominator and make something simpler, okay? And it's very tempting here when you've got variables attached with addition and subtraction to attempt to do that first without doing any math, but if you do, you're going to get them all wrong. You cannot cancel things out that are attached with addition and subtraction. You can only cancel things out if they're attached with multiplication, okay? So something over top of itself, if you have something on the numerator and you've got two things multiplied together over two things on the bottom that are multiplied together, and two of those things, one from the top and one from the bottom, are the same, then you can cancel out. You cannot cancel, like here, the a squared over a squared. You cannot cancel that and say it's 1. That's completely wrong. Now I want to show you why that's wrong before we get into the factoring. Okay, I've got the same problem here, and what I've done is I'm just going to pretend like I'm going to pick a random number for A, and I just picked 4, okay? So if I pick 4 for A and plug 4 in for all of these, anything that works for numbers will work for variables. Mathematically, if they don't work for numbers, then they're not going to work for variables, because those rules all do stand up under whether you're doing numbers or variables, okay? So if I replace a variable with a number, mathematically, if this works, then, canceling should work, okay? But mathematically, if it doesn't work, then you can't do it, okay? So if you think about this, if I replace all the A's with 4, okay? And if we do the math there, we'd use order of operations. If we do the math, we'd have 16 minus 4 minus 6 is 6. And then if we do the math here, 16 plus 28 plus 10 is 54. And then if we simplify that fraction, we should get 1/9 if what we do is correct, okay? So I'm going to do this the wrong way and show you why it's wrong with numbers, okay? If I say, okay, that's 4 squared minus 4 minus 6. I'm just doing the same thing. Over 4 squared plus 7 times 4 plus 10. Well, if I try to cancel things out that are attached with addition, look what would happen. Well, if I say, okay, 4 squared cancels with 4 squared, that leaves me with a 1. Okay? And we can say that's a 1 on top. It really doesn't matter. We could say it's 1 over 1. It really doesn't matter which way you do it. Here, if we say 4, this 4 cancels with this 4, so that leaves me with a minus 1 and a plus 7. And then if we say, okay, the 6 and the 10, that leaves me with a 3/5. That was a minus, that was a plus. This is a common misconception with your numbers. Well, if you do that, 1 minus 1 is 0, minus 3 is -3. 1 plus 7 is 8, plus 5 is 13. We get -3 over 13. Mathematically, we know that's incorrect because we know order of operations is what we're supposed to do here, okay? So canceling things out before we factor is completely wrong. But when students see variables over top of each other like this, it's very tempting to try to do that, okay? I tell my students if they do that on a test, they're not getting any partial credit or anything. That's just completely wrong. Until they can get out of that, then they're not doing anything right, okay? They have got to factor first. So my advice to you is when you see a trinomial, the first thing you're going to look for is, can it be factored? If it can be factored, then you can probably simplify it. You don't ever want to do this. This is just completely wrong. If you put that on your paper, it's trash. It just needs to be thrown out, okay? So what we're going to do with this is we're going to factor the trinomial, just like we learned earlier in the chapter. So if we factor the top and then we factor the bottom, we're going to look for common factors that they have. Okay, so, and this is why you need to be really comfortable with factoring. You're going to have a trinomial over a trinomial. You may have 3 or 4 trinomials in the same problem that you have to factor. So if you're still struggling to get those right, then it's going to be impossible for you to get very many of these right, because you have to get all the factors correct, cancel out all the ones that they have in common. So again, if you're uncomfortable factoring trinomials, if you can't do it really quickly, then you need to stop this lesson, go back, practice some more trinomials. You can use IXL. If you have me in class, you can come get extra practice. I have all kinds of practice, okay? Just let me know if you need it if you're in my class. If not, there are all kinds of resources, Khan Academy, online that you can use, okay? So get that practice in before you try to go any further. All right, so if I factor the top here, factors of 6 that subtract to give me 1. Well, that's 3 and 2. So if I factor the top, and I'm going to go pretty quickly here, we've got 3 and 2. Signs are different. Minus goes with the bigger number. I've factored the top. On the bottom, factors of 10 that add to give you 7. Well, that would be 2 and 5. The plus tells me the signs are the same as this, so they're both pluses. At this point, this is where I can cancel common factors, okay? So you have 2 factors up here, you have 2 factors here. I am only allowed to cancel things that have addition and subtraction in them if I'm canceling the entire factor. And remember, factors are things that are multiplied together. Factors are never added together. Factors, a minus 3 is a factor and a plus 2 is a factor. These 2 factors are multiplied together. You're only allowed to cancel complete factors, okay? So this factor, a plus 2, matches this factor, a plus 2. So I'm allowed to cancel those out because they are both multiplying everything else on that section, okay? So I'm allowed to cancel. As long as I'm canceling from the top and the bottom, I'm allowed to cancel. I cannot cancel 2 things that are beside each other. So if I'm canceling from a numerator and a numerator, that's wrong. I have to cancel. One of them has to come from a numerator. One of them has to come from a denominator. Okay? Once that's done, that's technically kind of like multiplying by 1. Those are gone. So my answer is a minus 3 over a plus 5. That is all I can do. Again, it's tempting. A lot of kids try to cancel the a's and get negative 3/5. That's completely wrong. You can only cancel out if you have common factors that are multiplied together, okay? So this is your final answer. There is nothing else I could do there. That's all I can do. And if you think about it, going back to this example, where I said let's let a equal 4. Well, if I let a equal 4, 4 minus 3 is 1. 4 plus 5 is 9. 1/9. Or mathematically, it's correct. We factored correctly and mathematically got something that would give us the same thing if we were using all numbers. All right, so for the rest of the notes in this section, I'm just going to do some examples. We're going to factor, we're going to cancel some things out. I'll try to point out common mistakes, and then I'll give you a few to practice on your own, and then we'll go from there. The top here, x squared plus 2x minus 3, factors of 3 that subtract to give me 2. That would be 3 and 1. The signs are different. The plus goes with the big number, so it goes with 3. Factors of 12 that add to give me 7 would be 3 and 4. They're both the same sign and they're both pluses. I'm going to cancel the common factor they have, the x plus 3, and my answer is x minus 1 over x plus 4. That's all I can do. Notice they're not always going to be trinomials. That's okay, but we can still factor this. First thing you're always going to do is factor out the greatest common factor. That still applies. The greatest common factor on the top is 2y. I'm going to have a y plus 4 left. On the bottom, notice that's a difference of squares. This is why we stressed difference of squares before. You have to be able to recognize it. You have to recognize it quickly and understand what to do with it. When I factor difference of squares, I have a y plus 4 and a y minus 4. Notice the y plus 4 is the same in both of those. Oh, and keep in mind too, this is another common mistake I see. If the sign is not the same, like this, that's a 4. This says y plus 4, this is y minus 4. Don't try to cancel the y plus 4 with the y minus 4. That's a common mistake, so don't do that. The y plus 4s cancel out, leaving me with a 2y over y minus 4. And again, we could not cancel the y's. This y is attached with a subtraction sign, so that's all we can do with that problem. In this one, we're looking for factors of 8 that subtract to give me 2. That would be 4 and 2. It's a minus 4 plus 2. On the bottom, we're looking for factors of 14 that subtract to give me 5. That's 7 and 2. Different signs, a minus 7 plus 2. And then the x plus 2's cancel. So that leaves me with x minus 4 over x minus 7 as my answer. They can get more complicated. We could have several trinomials in the same problem. We could have trinomials mixed with sum and difference of cubes. Trinomials mixed with difference of squares. So they're all different types of possibilities you might have. Looking at these on the top, we have 2 trinomials we have to factor. Factors of 2 that subtract to give you 1 are 2 and 1. Plus 2 minus 1. Factors of 1 that add to give you 1, there aren't any. We don't put prime there, we just bring it down as part of our numerator. We can't factor it, so it's still there. It's not gonna go anywhere if it doesn't factor. We don't put prime, that's not what we're doing here, okay? We're trying to simplify the fractions. X cubed minus 1, that's the difference of cubes. So to factor the difference of cubes, remember we have 2 sets of parentheses. In the first set, we have the x and the 1, the cube root of each of those. In the second set, I square this number. I multiply these 2 numbers, and I square that number. And then my signs are same, different, plus. Same as that sign, different than that sign, always a plus. And then these 2 don't factor, so I'm just going to bring them down. And then let's look and see what factors we can cancel out. What do they have in common? Well, the x minus 1 and the x minus 1 are the same. They can be canceled out. The x plus 2 and the x plus 2 are the same. They can be canceled out. The x squared plus x plus 1 is the same as the x squared plus x plus 1. Since they are exactly the same, they can also be canceled out. So we have left an x plus 1 on the bottom, and then everything on top had canceled. Hopefully you know that if everything on top cancels, it's understood to be a 1. You have to put the 1 when everything cancels on top. You cannot leave it blank. The answer, if you just put x plus 1 as your answer and leave the top out, it will be wrong. You have to have the 1 on top. But if everything cancels on the bottom and you're left with something on top, you don't have to have the 1 on the bottom, okay? That's something you should know from doing fractions earlier in your math career. All right, looking at this one, we're going to factor anything that factors. The x plus 2, nothing can be done with it. The x squared minus 4 is difference of squares. That's x plus 2 times x minus 2. Nothing can be done with the x minus 1. On the bottom, we've got 2 trinomials we're going to try to factor. Factors of 2 that add to give you 3, well, that's 2 and 1. Signs are the same and they're both minus. Here, factors of 4 that add to give you 4. That's 2 and 2. Both the same sign, both plus. All right, so let's look at what we have. This x minus 2 will cancel with this one. This x minus 1 will cancel with this one. This x plus 2 cancels with this one. This x plus 2 cancels with this one. What should I put for my answer? Common mistake is 0. People put 0 there because everything canceled. 0 would be the answer if everything cancels because of addition or subtraction. When everything cancels because of multiplication or division, the answer is 1. Very common mistake. Be careful. Don't make that mistake. The answer is 1, not 0. Here are 2 more examples. But this time, so far the factoring that I've done has been very, very simple. We haven't had any coefficients of the x squared term, anything other than 1. But you need to understand sometimes that might happen as well. So I wanted to make sure we did some trinomials that have coefficients other than 1. Okay, because that's very important. It's really important that you can do those quickly as well. So looking at this, with the 6x squared minus 5x minus 4, to factor that, I have to multiply the 6 times 4, which is 24. Are there factors of 24 that subtract to give me 5? That would be 8 and 3. Okay, 8 and 3. So we need to make an 8 and a 3 with our outside and inside terms. To make an 8 and 3, factors of 6 that would probably be used would be 3x and 2x. And then 3 times what gives me the 3? That's 1. 2 times what gives me the 8? That's 4. 4 times 1 is 4, so we know we've got all the numbers correct. Now we have to deal with the signs. We know that they have different signs, and the big number, the 8, gets the minus. So in order for the 8 to be negative, that's a minus and that's a plus. For x squared minus 1, that's difference of squares. That's x plus 1, x minus 1. So hopefully you're seeing why you need to be able to factor trinomials quickly to be able to do this section. So again, if you need more practice with that, practice that first before you attempt this one. X cubed plus 1, that's our sum of cubes. So we have an x and a 1, x squared, x and 1. Same, different, plus. On the bottom, we have to factor 3x squared minus 7x plus 4. So we have to multiply. 3 times 4 is 12. Are there factors of 12 that add to give you 7? Yes, that would be 3 and 4. So we need to make a 3 and 4. I do my 2 sets of parentheses. Factors of 3 would be 3x and x. 3 times what gives me 3? That would be 1. 1 times what gives me 4? That would be 4. 4 times 1 is 4. Signs are the same, and they're both minus. So we've factored all the trinomials there. We've done all the factoring that we can possibly do. Then we're going to cancel out anything that they have in common. Look here, I've got x minus 1. I can cancel that out. X plus 1, that cancels. 3x minus 4, that cancels. It really doesn't matter what order you cancel things in as long as you're getting them all canceled out that you need to. And then here, are there factors of 1 that add to give you 1? No, they're not. So you can't do anything there. So my answer is going to be 2x plus 1 over x squared minus x. And then for this one, hopefully you notice this is difference of squares. This is also difference of squares. So if we factor that, the square root of 9x squared is 3x. Square root of 4 is 2. We will have a plus and a minus. Here, the square root of 4x squared is 2x. Square root of 25 is 5. And we have a plus and a minus. On the bottom, that thing is squared. If that is squared, that just means that we have 2 of these. So if what we have here factors, then we're going to have 2 of each factor. That's all that means. To factor that, I'll do 6 times 10, that's 60. We're looking for factors of 60 that subtract to give you 11. That would be 4 and 15. 15 minus 4 is 11. So if I factor that, we want 4 and 15 using the 6. So I would say we need the 2 and the 3. So 2x, 3x. 2 times what is 4? That's a 2. 3 times what is 15? That's a 5. And 5 times 2 is 10. So we know we've got those numbers correct. And then we need to do signs. They're the different signs, and the plus goes with the big number, the 15. So we need a plus 15 and a minus 4. And then that was squared. If that's squared, that just means we need to write each of those down twice. So we've got 2x plus 5, 3x minus 2. And I'm going to then cancel. So 2x plus 5, 2x plus 5, 3x minus 2, 3x minus 2. And it looks like that is all I can do. So I've got 3x plus 2 times 2x minus 5 over 2x plus 5 times 3x minus 2. And that is all I can do with that. So there's nothing else that cancels. I can see where it would be tempting to try to cancel that and say, oh, that's -1. That's completely wrong. Remember, the factor has to be exactly the same before you can factor anything out. So that is not -1. You just have to be real careful about that. If you're still uncomfortable with factoring trinomials, sum and difference of cubes, or difference of squares, please practice that some more first before you attempt these, because it only gets more difficult from here. The next section that we're going to do is multiplying two of these fractions together and then canceling out. So it only gets more and more difficult from here. Get comfortable with factoring trinomials first. Extremely important.